So this is a continuation on of sigma notation. So what we're going to look at now is S of capital N, S of n essentially. And this is generally used to denote the sum to n terms of a series. So, for example, it's a sort of intermediate sum, so to speak. So in the series 1 plus 3 plus 5 plus 7, S of 4 is the sum of the first four terms, sum of terms 1 to 4. And in general, S of n is the a of 1 plus a of 2 plus a of 3 all the way up to a of n. So that's how we might write it there, where a of r is each individual term. So it's just the summation of each term from r equal to 1 to r equal n, some value. Now consider the sequence a of n, where that is equal to x to the power of n minus 1 divided by x minus 1 factorial for any given x. And those are some example terms there. 1, x, x squared over 2 factorial, x cubed over 3 factorial, and so on. S of 1 would define the sequence of numbers that are defined in terms of x. So S of 1 is simply 1. S of 2 is the first two terms, and in this case that would be 1 plus x. S of 3 would be 1 plus x squared over 2 factorial. So it would be these first three terms, and so on. So you get the idea then. This is S of 4 here, this term here. Okay, so that's a 4 there, sorry. Let's make that a bit clearer. So this is in fact a converging sequence whose limit is e to the power of x. Now that's something that is going to come up later. But therefore it is possible to define a limit in terms of a series. So S of n of x in this example here is e to the power of x. Now this is just a special case, and what we're sort of setting something up here. So let's go to the next slide. So if a of n converges to a limit L, we can write this as follows. L is the summation from n equals 1 to infinity of a of n. Now to test it and see if a series is convergent, we use this thing called a ratio test. So this is what I'm sort of aiming towards here. Now the ratio test. Now in the previous section we have just established that the sum to infinity of a series is defined as the limit of S of n as n tends to infinity. When a series has a limit, that's how we would write it, when the limit is finite, tends towards a particular value, we say that the series is convergent, or it converges. And when it has no limit, it tends to infinity, we say it is divergent, or it diverges. So this is a very simple test. To check if a series converges or not, we use the following simple test, and it's the ratio test. Let the sum of a of n be a given series such that the limit of as n goes to infinity of the absolute value of a of n plus 1 divided by an is equal to p. Now there's some ratio here, and what we're going to do is a of n plus 1 divided by an, there's some ratio there, p, or the absolute value. If p is less than 1, the series is convergent. If it's not, if it's greater than 1, it's divergent. Otherwise, if it's equal to 1, the test is inconclusive. Now, a ratio test is generally used to test for convergence or divergence, in which a series is in a series in which the variable, generally n, appears in factorial form, something like that, 3 times n factorial over n plus 1, or the variable appears as a power, 2 to the power of n over n squared. So these are the sort of really tricky ones that you have to figure out.